So here's the problem we're trying to solve here. We're told that the coefficients of the first three terms in the binomial expansion of ax plus by to the n are 16, 96, and 216. We want to find the values of a, x, and n. So this is a fairly lengthy question, so you might want to pause for a minute here, write down the question before we really get going here. What we're going to do is we're going to use our standard formula here for the binomial expansion. Okay? And the thing that we want to expand is this thing that they give us, ax plus by to the n. And when we're doing a binomial expansion, the first thing that we probably want to do is identify what in the thing that we want to expand corresponds to this a and this x in our formula here. So the a and the x in the binomial formula correspond to ax and by in this thing that we are trying to expand. Now normally we would ask ourselves, what is the value of n? What is the value of k? Well, there's no way of figuring those things out. N is one of the things that we're trying to solve. Okay? So let's just go ahead and apply our binomial formula here and start doing our expansion. So if we're expanding ax plus by to the n, give myself a new line here, our first term is going to be, our k equals 0 term is n choose 0, ax to the n, and then by to the 0. Our next term is going to be n choose 1. Again, we're going to have ax, this time to the n minus 1, and then we're going to have by to the 1. And then I'll do our third term here. Down below is going to be n choose 2, ax to the n minus 2, by, all to the 2. And I don't really need to go beyond that because we're only given information about the first three terms. Where should I go from here? Well, I can simplify these things a little bit here. I know that n choose 0 is just going to be 1, so this first term, I just apply that exponent n to both the a and the x, so I get a to the n, x to the n, and b to the y is just 0. My next term, I've got n choose 1. That's just going to be n. And then I can apply this exponent of n to the minus 1 both to my a and my x. So I'll have a to the n minus 1, x to the n minus 1. And then I'll have a b and I'll have a y. My third term is going to be n choose 2. I don't really know what to do with that yet, so I'll just leave it as n choose 2. But again, I can apply the exponents to everything inside the brackets. A to the n minus 2, x to the n minus 2, b squared, y squared, plus again, dot, dot, dot. What I'm interested in is the coefficients from the terms in this expansion. So the coefficients are just the numbers part, so I can get rid of sort of the variable part. So anything that has an x and a y in it, I don't really need. So I don't really need this x to the n. I don't really need this x to the n minus 1. I don't need this y. I don't need this x to the n minus 2. And I don't need this y squared. So let's just pull out the coefficient part for each of these. So I'll just say coefficients. My first term, my coefficient is just going to be a to the n. And we're told in the question that that is equal to 16. My second term, my coefficient is just going to be n a to the n minus 1 times b. And we're told that that is equal to 96. And our third term, our coefficient is a little bit more complicated. We still have this combination in here, n choose 2, a to the n minus 2, and then we've got b squared, and we're told that this whole thing is equal to 216. Now these are the equations that we are going to be working with. We've got three equations. Okay, I'm going to call this one number 1. I'm going to call this one over here number 3. And I'm going to make a little change to this one in the middle. I am going to take, like over here we've got in equation 1 we have a to the n equals 16. So we just have a on one side. I'm going to rearrange this middle equation to solve for b. So b is going to equal 96 divided by n a to the n minus 1. And that's what I'm going to use as equation number 2. So getting to this point, this is all of the, well, this is most of the binomial theorem stuff out of the way. The rest of it is just algebra, taking these 3 equations and combining them together to solve for what we want to solve for. The equation that we're going to work with is equation number 3. So equation number 3 is n choose 2, a to the n minus 2, b squared equals 216. I've got n, I've got a, I've got b in there. I want to take things from equation 1 and equation 2 and substitute them into equation 3. Let's label this equation 3 here. Before I do that, though, I'm going to look at this n choose 2. Is there a way that I can simplify n choose 2 to make it a little bit easier to work with? Well, let's see. N choose 2, if we apply our combination formula, is going to be n factorial over n minus 2 factorial over 2 factorial. I can simplify this factorial expression. I can rewrite n factorial as n times n minus 1 times n minus 2 times so on and so on and so on, or just n minus 2 factorial. Down on the bottom, I've got n minus 2 factorial, and I've got 2 factorial, but 2 factorial is just 2. So you can see here that this n minus 2 factorial and this n minus 2 factorial are going to cancel out. And then I can just write this as n times n minus 1 all divided by 2. So this is one of the things that we're going to substitute into equation 3. The other thing that we want to make a substitution for is this b squared. So the other place that b appears is in equation number 2. So let's look at equation number 2 here. It tells us that b equals 96 over na to the n minus 1. So if we square both sides of it, we'll get an expression for b squared. So 96 squared divided by, we'll just square everything in both the numerator and the denominator, so we'll have n squared, and then we'll have a n minus 1 all squared. So it gives us 96 squared. Let's evaluate 96 squared at this point. So that gives us 9216 divided by n squared. And then if we're doing a to the n minus 1 squared, we've got an exponent to another exponent. We multiply the powers together. That'll give us a to the 2n minus 2. And that is what we're going to substitute in for b squared. So let's make those 2 substitutions right now. So equation number 3 becomes n times n minus 1 divided by 2. Okay, making our substitution for that combination. We still have the a to the n minus 2. And then making our substitution for b squared, 9216 divided by n squared a to the 2n minus 2. And this whole thing is still equal to 216. Now that we've done this, we can see some things that might cancel with one another. We see some n's in the numerators, some n's down in the denominators. We've got some numbers in the numerator, number in the denominators, things like that. So let's just line up the things that might cancel out. I've got n times n minus 1 in my numerator up here. Down over here, I've got an n squared in the denominator, so let's just write that like that. Here I've got an a to the n minus 2. Down in my denominator here, I've got an a to the 2n minus 2. And then I've got a 9216, and then I've got a 2 down in my denominator over here. The whole thing is still equal to 216. So let's do some canceling here. That's going to cancel with that to leave us with n minus 1 over n. When we look at a to the n minus 2 divided by a to the 2n minus 2, we are dividing powers of the same base, so we have to subtract the exponents. So I'll just, over here at the side, if we're subtracting these exponents, we have n minus 2 minus 2n minus 2, which is going to be n minus 2 minus 2n, negative negative 2 is positive 4. Sorry, not positive 4, positive 2. And that's good because now this negative 2 and this positive 2 cancel out. So n minus 2n is just negative n. So we're left with a to the negative n, or 1 over a to the n. The negative just means it's going to be down in the denominator. And then 9616 divided by 2 is just 4608. This whole thing is equal to 216. So we've gotten rid of b in equation 3. We still have n, and we've got a to the n here. But remember, if we go back, equation number 1 told us that a to the n was equal to 16. So let's sub that in right here. I should do this in red. We'll make that substitution for a to the n. So now we have n minus 1 over n. Making that substitution gives us 1 over 16 times, 4606 equals 216. So where do we go from here? Well, I think it's pretty clear. We can do 4608 divided by 16 to get n minus 1 over n equals, what is that going to be when we do that division? It's going to be, oh, let's just write this out here. 4608 over 16 equals 216. When we do this division, we are going to get a fraction here. Okay, so, oh no, we don't get a fraction. It works out nice and easy. We get n minus 1 over n times 288 equals 216. If we divide both sides by 288, n minus 1 over n equals 216 divided by 288. And if we express that as a fraction in lowest terms, 3 over 4. Now we've got something we can solve for n. If I just cross-multiply, so cross-multiply kind of like this, okay, just ignoring that thing in the middle, I get 4n minus 1 equals 3n. So 4n minus 4 equals 3n, so n equals 4. Just solving that little equation there. Now I've got my value of n. So that's one of the 3 things I was looking for here. I can use that value of n back in equations number 1 and 2 to try to solve for other things. So if we go back to equation number 1, which was a to the n equals 16, this becomes a to the 4 equals 16, and a equals 2. Now technically a could be negative 2 as well, but we'll just assume that both a and b are positive here. So now we've got 2/3 of the things that we are trying to solve here. What can we do with this value of a? Let's go and use equation number 2. equation number 2 was that b equals 96 over n, a to the n minus 1. We know what a is, we know what n is, so let's sub those in. If n is 4, a is 2, we end up with b equals 96 divided by 4 times 2 to the 4 minus 1, or 96 divided by, let's see, 4 minus 1 is 3, 2 to the 3 is 8, 4 times 8 is 32. So 96 divided by 32 tells us that b is equal to 3. And there we have it. The values of n, a, and b.